Well, good day, guys. Welcome to the fourth edition in a series of how to become a software developer. Everything we've really discussed up to this point is basically common to all languages. I know this is basically a C# course, but everything covered so far is the same for all languages, and today is going to be no different. We are going to be doing some C# coding. But the subject we're discussing today, which is conditional statements and loops, are it's the same for all languages. That's one of the very important things. You know, once you start understanding these programming concepts, it doesn't really matter what language you're using. That's why for some people it's very easy to learn multiple programming languages. You know, not just one or two, but 10, 15. It's because you understand the basic constructs of what programming is about. So yes, so like I say, today we're going to be looking at conditional statements and loops, and in specific, maybe a quick description of a conditional statement. A conditional statement is if you want to do something, you can only do it on the condition that some requirement is met. Okay, so a perfect example of this is one of the most used commands in programming languages is the if statement. All right. So you could, for instance, with some pseudocode say something like, if my friend is older than 50, then do something. And that's it. That's all you have to do. Okay, so that is the most simple if statement that you can have. It's got a condition, all right, which is my friend older than 50? And then if it is, it goes ahead with the next line and does what it's supposed to do, print it out or whatever the case may be. But if your friend is not older than 50, okay, so that conditional statement is not met, it's not true, it must always evaluate to true. Okay, that's where Boolean logic and so forth comes in again, as we learned on one of the previous videos that I did. But you can have multiple paths you can follow in an if statement. Showing you now just a single if statement is if my friend is older than 50, then do the following. But you might want to say if my friend is older than 50, do this. Else maybe if my friend is older than 20, do this instead. Else in all other circumstances do this instead. Alright, so we can look at some code for that, and I'll talk you through how the evaluation is done. Alright, so I've started up Visual Studio. Visual Studio is the program which you're going to be used to writing your C# code in. There are other environments, let's call them, in which you can write C# code, but the correct terminology for these environments are integrate development environments, IDEs. Some environments or IDEs are not really IDEs, they're just glorified notepad editors. But an integrated development environment is a typical environment that has got many tools that you require for your development. More than just the actual writing itself. You can do all sorts of other weird and wonderful things in it, and that's what makes things like Visual Studio so extremely powerful. This one in particular is called, like I say, Visual Studio. You get a free version or a community version of it, which is what we're looking at right now, and it's very powerful, can handle very large projects. In fact, some of the projects I've been working on for big clients over the last number of years has all been on this free version. But there are, like I said, there are others. They also have Microsoft has another version which is called Visual Studio Code, which you can also do C# coding with, for instance, on Linux, Windows, Apple, etc. But alright, so what we're basically looking at here now is our pseudocode converted into real C# code. Okay, and you'll notice, okay, there's a few things that might confuse you at the moment. We're going to be covering them later. So if we start from the top of the code section, you'll see there's the word using system. Under that, namespace, then class program, then static void main. All right, and under that, int my friend's age. All right, for our purposes at the moment, you can ignore all those other things for now. Alright, and our code that we're looking at actually starts at int my friend's age equals 50. Alright, so like I say, this is that pseudo code that we've now converted to actual C# code, And so you have an if statement, and you can have multiple else's to that if statement. You can have 20, 30, 40. The very last else you see here, where it says else you are still in your carefree years, you might not want to include that else. You might just want to have if else, and that's it. So in other words, an if statement in its simplest form would, for instance, be just an if does some condition or checks for a Boolean condition, in other words, a condition that evaluates to either true or false. All right. If it evaluates to true, then you'll see under the if my friend's age is greater than 50, there's these little curly braces. Now in C#, those are called blocks. All right, and that basically keeps a piece of code together so that it's treated as one piece of code. So in our case now, we only have one line in our first block, which is console write line you are experienced, but you can have many lines in there. And if that if statement evaluated to true, all right, it'll go in and execute all those lines inside that particular first if statement's true block. If it didn't evaluate to true but to false, then it moves on to the next if, okay, and it sees does that evaluate to true. All right, if it does, then it goes in and it says looking good. But if that doesn't evaluate to true, we say then else. So in other words, in all other circumstances, we want to print out the word you are still in your carefree years. So in other words, according to this code, if your friend is older than 50, all right, it'll print out you are experienced. If your friend is not older than 50, but he is older than 20, it'll print out looking good. And in all other circumstances, in other words, anything under 20 or 20 and less, it's going to print out you are still in your carefree years. All right, now what are we looking at? When I say if my friend's age, and I got that little sign, you should recognize it from your mathematics days. That's a greater than sign. Okay, so if my friend's age greater than 50, all right, so this is where you can see that's called a Boolean operator. Okay, this is where you can see that you are doing some form of evaluation that will result in a true or false. So you're saying if my friend's age is greater than 50, so you're telling him I want to check the age and is it greater than 50. It either is going to be greater than 50 or it's not going to be greater than 50. All right, because we're working with a number here now, an integer. You'll remember when we looked at primitive data types, we covered integers. This int is just the default int that most people just use as is in C# when they're not too worried about giving a particular data type, because this int can, it's a signed int. It can handle minus and positive numbers. Now you can argue that in this case that is not quite the correct data type to use, because why are you using a data type where a person's age is allowed to be negative, below 0? Yes, you are correct. One should use the correct data types and so forth, but sometimes just for ease, just throw in an int or whatever the case may be. But it is much better self-documenting code if you use the correct data type. It tells yourself what you actually wanted to do in the upcoming code, and also tells somebody else that's maintaining your code what your intentions were. So this is saying that, oh well, your friend's age can go up to 2 to the power 31. That's obviously not true. So a better data type here would have been a byte. Alternatively, you can create your own data type, but that we'll get to at a later stage. Alright, so if we look at the different Boolean operators you have, you'll note that given two variables, A and B, an evaluation will be done on them that will always result in a true or a false. Okay, so if we look at our first example, A equals B, obviously A either equals B or it doesn't equal B, so it's a true or false. Okay, the same would apply to the next one, A not equals B, so either A is not equal to B, all right, which is a result of a true, in other words, or it is equal to B, which in this case will result in a false. Okay, let's say we look at the next one, A greater than B. So it's checking there that is A greater than B. If it is, the result will be a true, and if it isn't, the result will be a false. So in an if statement, if A is greater than B, it'll go into the first block, and if it's not equal to not greater than B, it will either go to a next block or quit the if statement entirely. Then you'll notice a little bit further down you can have greater than or equal to B, as well as a smaller than or equal to B. So you save there by first checking that is it equal, and if it's not equal, then checking is it greater than. So instead of having two statements, you can do it in one go. You can just say is A greater than or equal to B, and that'll result in a true or false. Okay, you'll notice here that the very first one, A equals B, that A equal B, it's got two equal signs. All right. When you're setting a variable to have a particular value, all right, you use a single equal sign. All right. You'll notice like where I set the age here, for instance, of my friend. So that's when you actually set the value of a variable. But when you're doing an evaluation of the value, all right, then you have to use a double equal. It's just so that, to avoid confusion and so forth, just remember that if you ever do a double equal, that means you're doing a Boolean evaluation, and if you're doing a single equal, that means you're actually setting the value of a variable. Alright, so if we go back to our C# code, what I've shown you here is basically that you've got a very simple if statement, a if with a command block, and or you can have an else on it as well, if else. Alternatively, you can have multiple if statements combined with else. So if A equals B, else if A greater than B, else if. So you keep saying else if, else if, else if, and when you get to the very end, you might want to have a catch-all and just say else, and then everything else will be captured by that else if one of the previous one didn't evaluate to a true. Okay. So if we want to go for something a little bit more complex, that maybe inside a if statement you find you need another if statement. Okay, these are called nested statements, nested if statements. Okay, so you can have a piece of code which evaluates to true, for instance, with an if statement, and inside that block that it is now just entered, it does another if statement. But it'll only do that if statement if the evaluation for this block was true. If the evaluation for this particular block was false, then you'll never reach the second if statement, this nested if statement. Another thing that's important to remember about if statements is the way that the evaluation takes place. So in this example, we're looking at, for instance, we've set a byte data type for a variable to the value of 2, and then, as you now know, it'll go through the if statement and it'll try and find the first match where day of week is equal to 2. So it'll hit the first one. Okay, it'll see no, it's not 2, so it'll skip that. Then it'll go to if day of week equals 1, so no, it's not that, and it'll skip that. Then it gets to day of week equals 2, and it'll see yes, that evaluates to true. The variable and the constant name is the exact same. So it'll then go in and write to the console the word Wednesday. But the problem is, once it's finished writing out Wednesday, it's going to continue down the line of code. And the next thing says is if day of week equals 3. But we've already finished evaluating for day of the week. Why are we evaluating again for 3? We should not. We should stop after we've gotten to 2, because we're doing extra work now. So what you can do is then just remember the importance of using else's. So don't use a whole lot of just if cases, because that means every single if is going to be evaluated. Sometimes you only want some ifs to be evaluated, and once the first one is found, the first true is found, you want to break out of this whole if evaluation process that you're going through. So if you look at this example, you'll see it says, okay, if day of week equals 0, which it isn't, and then it'll day of week 1, and then day of week 2, which it is, and then it'll print out to the console Wednesday. But then all the ones after that, Thursday, Friday, Saturday, and Sunday, will never even be looked at. That code will never run. So in principle, your evaluation of that entire, to get the day of the week is twice as fast, okay, because you're using else if instead of just if. Another construct that exists as an alternative to using the normal if statement with the if else and so forth is to use what is called a switch statement. And the switch statement is basically you supply it a variable to work on, like in this case day of week, and you can then check by using the word case. Each one of those are little blocks, case 1, case 2, case 3, so that each one of those would have evaluated to else if, else if, else if. So this is basically an else if else statement with else ifs in it. It's just a different way of writing it. There are a few other little changes, but basically it's the same thing, and especially with very large if statements, well, firstly you should be separating your code into separate functions, but it's easier to keep track of what's going on with a switch statement if you've got a lot of code. Then on the switch statement you also have something right at the bottom here. You'll notice here there's a default. Now that equates to the if statement's final else, not else if, just else. So if all the other conditional statements did not work, instead of just going ahead, carrying on with the program and doing nothing, that you can say, okay, then in this case, because nothing else was matched, run the default code, which it does in this case. I'm telling you, that's not a valid day. And yes, all right. So that's looking at the if and the switch statement. We'll get to a little bonus after this. But just to discuss another thing, when you're doing your conditional statements in an if statement, you can have more than one statement that evaluates to a true or false. So far we've only been looking at, for instance, if a person's age is greater than 50. All right, that's one statement, one conditional statement. It is possible that you might want to say if he is greater than 50 but smaller than 70. All right, then you want to do something. So what you'll see is in this particular case what we've got, we're dealing with days of the week again, and so we've the day of the week being 2 now as our starting point. So what our first conditional statement does is it says if day of week is greater than or equal to 0, which is true, it is. So once it's done that evaluation and it's seen it's true, then it sees that it must do an AND. So it must AND it with another evaluation. So it's 2 Boolean evaluations. So if you ever see 2 ampersands next to each other in a conditional statement, it's meaning that you need to do 2 conditional or 3 or 4 or 5, how many conditional evaluations you want. So in this case we're only doing 2 evaluations. All our examples so far has only been 1 evaluation. For instance, is my friend's age over 50? Now it's at the day of week is greater than or equal to 0, and then still after that you do an AND, day of week is also smaller than 4. So there's 2 conditional conditions that you're evaluating there. Now the thing is, when you're working with an AND requires both of your evaluations to result in a true before it'll enter the block, the success block. So in other words, the day of the week in our example now is a 2. So because the day of the week is greater than 0 and day of week is smaller than or equal to 4, therefore it'll change the value of result to time to work. Okay. Now, and like I say, you can have multiples of these. You can mix ands and ors together and so forth as well. So if you go a little bit further down on the string, let's assume that the day of a week is not a 2, but let's say it's 5. So you now move into, so your initial evaluation, your double bool evaluation there of greater than 0 and smaller than 4, doesn't succeed, so then it goes into the else. And the first statement inside the else is another if statement, all right? And it says, if day of week is equal to 5, all right, which it is. Okay, we just stated that day of week is 5. I know it says 2 on the screen, but let's just stick it in our minds. We've changed it to 5. So the first if will work. Okay, sorry, the first conditional statement will work. Now, opposite or different to and statements, where and statements, both of them or all of them must evaluate to true. Okay, in total, all of them anded together must be true. All right. With an or statement, only one needs to be true. All right. So, like in our case now, day of week is 5. So we don't really worry about the or day of week equals 6, because we've already succeeded on the day equals 5. If day equals 5 did not succeed, so let's say the day of the week was actually 6, so it comes into the else and then it goes into the if day of week equals 5, that will fail. All right. But then there's the or, and it says or day of 6 equals 6, day of week equals 6, and that does succeed, and it'll change the value of the variable to its weekend. But let's say, for instance, we're running through this now again from the top. So let's say the variable's value is, let's say, 32, not 2, 32. Okay, the day of week is 32. Now that is not a valid day. All right, your days are from 0 to 7. So when we get to our if statement here, our first evaluation is going to fail, because the day of a week is not inclusively between 0 and 4. It's also not day 5, and it's not day 6. All right. Then, in other words, our very last else statement there is going to be executed, and it's going to say such a day does not exist, and it's going to write the very last line, which is write that to the console, to the terminal. And yes, okay, so that's the basic workings of conditional statements. Now, like I said, I did have a little bonus for you. There's one that we use quite a lot. It's called a ternary conditional operator, and it's basically just a little shortcut for a quick if-else statement. So in your normal if-else statement, you'll have, for instance, a if, and then your binary comparison. You'll have a squiggly bracket. They consider it in C# bad practice to have your squiggly brackets on the same line as your conditional statements. It's got to be on the next line. Then you've got result equals else, and result equals again sad, etc. So we've actually got 1, 2, 3, 4, 5, 6, 7 lines there for that if statement, and you can quite literally just change that whole 7 lines to 1 line. And it does the exact same thing as what that if statement did. Now, these aren't always the solution to if statements. It's normally just for quick, short if statements. If there's, let's say, in your true evaluation, or even your false evaluation, or both for that matter, there might be a lot of code you want to stick in there. Then using the ternary operator is not the right way to go. This is just for a quick, simple little if statement. And yeah, so that basically brings us to the end of conditional statements, and we'll now be moving on to loops, which also uses conditional statements, but they typically use conditional statements so as to know when to break out of the loop. Else you could end up with something called an infinite loop, which means your program just sits around and spins in a little loop forever. There's got to be something that breaks out of the loop. And you can do something inside the loop itself to break out of the loop. Use the break command, or maybe return from the function. But the correct way to do it is actually to have the loop do some Boolean evaluation, and based on that, stop executing the loop. Okay, so the first loop we're going to be looking at is the probably most used loop out of the initial basic loops. And that will be your for loop. So the thing with the for loop is initially when you look at it, it might look a little bit daunting. I'm showing you here at the bottom the C# code version, and then on top just a quick description of how it works. I won't quite say it's pseudocode, but it's just a quick description. So it starts off with the word for, all right, and then in normal brackets, okay, it has its conditional statements and starting statements and all that, and then once it goes into the block, then it does something, all right, and it'll do that something for as many times as the loop is going to run. Alright, so the number of times a loop runs is, like I say, it's in the first normal brackets, not the squiggly brackets, the normal brackets. So if we look down at the C# one, you'll notice that it says for, and then int I equals 0. So what that's doing is it's saying that, okay, we want to counter, which we're going to use to count how many times we go through this loop. It's of data type integer, and its starting value is 0. You could make it anything. You could make it 1 if you want to, or you could make it 1,000. All right, it's just where do you want to start from? All right, and then you have a semicolon, and then again you have the I, which you've now just declared and said it's equal to 0. Then you say, okay, this loop must continue looping until I is no longer smaller than 10. So in other words, continue doing this while I is smaller than 10. And then the last little bit is the I++. Now plus is just a shorthand way in C# and some other languages of saying just increment the value of I. In other words, just add 1 to I. So what it's basically saying is the first time this loop it gets called, when it starts running, the first thing it's going to do is going to set I to 0. Then it's going to check, okay, is I still less than 10? Yes, it is, so we can continue with the loop. And then once it's gone through that loop, it's going to increment I by 1. So I is now no longer 0 but 1. So the next time we run through this loop, it will now say, okay, is I, which is now 1, less than 10? Yes, it is. Do the loop and then increment it by 1. You can change that increment value to 2 or 3 or 5 or whatever you want it to be, but typically it's just 1. Alright, so that's the most basic loop you get. The syntax is basically the same for most languages. I just mentioned the word syntax. That's the big difference between languages. A lot of these languages use all these same constructs and so forth. They've all got for loops, if statements and so forth. But the exact way they write it, the exact wording they use is called syntax. So it does the same thing as maybe a similar loop in another language, but the way you write it down is different. That's normally where people struggle when they move from one language to another. But if you know the basic constructs of programming, all you need to do is just learn the new syntax. Like for instance in this case here, I'm saying for int I equals 0. Now when you're naming variables, giving a variable a non-descriptive name, like instead of saying the index, just calling it I is normally frowned upon. You should name your variables properly. But I'd say due to being used so often, 30, 40 years, people have been using I for a loop counter, and then sometimes J as well, and a single alphabetic character, but they normally start on an I. So like I say, not naming a variables properly is frowned on, but in a loop, using an I is kind of okay, because everyone knows what you mean. That's why you want to name your variables properly, so that people know what this variable does. Now when it comes to a loop and you're using I, everyone knows what you mean, what I refers to, so it's okay. Okay, so then if we move on and we actually have a look at an example of a loop then in C#. Alright, so all this basically does is it creates itself a variable. Alright, it's a constant. So you'll see there's const, so that number cannot be changed. It's put into the program once, and you can never ask the user for a new value. You can never do some mathematical calculation and change that value. Const means it is set to that number, and that's what it is. and in this case it's set to, I can't read now, but I think it's 1,000,000. Okay. And then we have total, another variable. So we've got number of times to play, and then we've got total. Now total is a double, which means it's a floating point number, which means it's got a decimal point. Okay, because we're going to be doing some math calculation, and the answer could result in having a decimal point in it. Okay, so we've got this total. Now what we want to do, okay, what this little program must do is it must take 1,000,000 like coin tosses, let's say, okay, must choose 1,000,000 random numbers, okay, between 0 and 1, okay, and see what is the average of all those numbers. So quite clearly it should be approximately 0.5. So you know, if it's between 0 and 1 and it's a random number, it is very possible that they're all 0.1 or 0.8 or whatever, but typically a random number generator normally works out on the exact middle of the numbers that you generate in the random number, on the range, in other words. So in this case we're looking basically a coin toss, so it's a 0 and a 1, and so our average should be, the heads and tails should be basically the same, or zeros and ones should basically be the same. So if you run this little program, you'll always find that your answer here at the bottom where I say console right line average is that total divided by number of times to play is how you calculate an average. That's normal maths averages like you used to do at school, and it should be in the vicinity of 0.5. It's very possible it could be 0.9, but the chances are it's going to be in the vicinity of 0.5. So this is an example of where we use a loop. We say we want to play this game, or we want to flip the coin basically 1,000,000 times. All right, and that's what the for loop says. So we want to start at 0. The index variable we're using is I, okay, and we're saying while I is less than 1,000,000. All right, because that's the value of the variable numbers of times to play, although it's a constant, not a variable. And then we say, okay, every time though we want to increment the value of I by 1. So we're literally going to be counting from, or this loop is going to be running 1,000,000 times. It's going to start at 0, it's going to go 0, 1, 2, 3, 4, 5, all the way up to 999,999. Remember, just one less than 1,000,000. Remember, because we're starting at 0. You can start at 1 and then say if I equals 1,000,000. You can do that, but in programming we normally always start with zeros. It's just easier for many reasons. Okay, so if you wanted to, for instance, not run this thing 1,000,000 times, but only run every second time, so you don't want to count from 0, 1, 2, 3, 4, you can then change this I plus plus and say that change it to I plus equals 2, and that means I will be incremented by 2. Or you can say I plus equals 10, that means I will be incremented by 10. So let's say if it's I equals plus equals 2, so the first time it'll start on 0, then the next time it goes through the loop, it won't go through as a 1, it'll go through as a 2, and the next one is a 4, and 2, 4, 6, 8, 10. But that is often used, but nowhere near as often as just saying like I plus plus. You want each and every number to be done. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. Okay, and then another example we have here. This shows you how nice a loop is for going through very big arrays. So what I'm doing here is I'm creating a 2-dimensional array, which I just decided to call the 2D array, and it only consists of, like I say, it's a 2-dimensional array. It only consists of 3 rows and 2 columns. Okay, and you'll notice the moment I start using the 2D array, then I've got the square brackets. Of course, if you remember from a previous video, that's how we refer to let's call it a variable within an array, we've got to tell it what the index point is. So if this was a one-dimensional array, you'll just say 0 for the first one. But because this is a two-dimensional array, you've got to say 0, 0. All right, that points to the first one. And then, but remember I said it's 3 rows and 2 cells, all right, that can contain values. So the first 0 we put in, all right, refers to the row. So it's the first row, and then the first cell 0, its index is also 0. So that's our very, very first value in the array. And we're saying make that value 50. All right. The 2 slashes of green there, that is how you put a comment in C#. So I'm just saying that 50 refers to kilograms. Alright, then the next line, I say also 0, same as the one above was 0, so that's saying I'm still in the same row, but I'm moving to the second index now, because remember there are 2 indexes, or cells, 0 and 1. So it's 3 rows and 2 cells, okay? So this is how you'll populate a 3-row, 2-cell, 2-dimensional array. Now what I'm populating it with here is basically masses and speeds in meters per second. Now the reason why I'm doing that is because I want to calculate something to do with momentum. All right, so we could have created this 2-dimensional array and populated it, for instance, not by hand like I did now. I mean, I'd have a problem if I wanted to put, you know, 1,000,000 rows in here. You know, that I can't do that. So you'll read it from some input device. You might have a list of 1,000,000 rows in a file. It might be sensors from a car, something that can give you all this data instead of you writing it down by hand. But then to show you the difference, so the first part is now I'm writing it all down by hand, and then the second part is I'm not calling things out of it by hand when I do the calculation. I use a for loop, all right, and I'm telling it that, okay, I want to go through every row. Now remember I said there were 3 rows, so we start with for int I equals 0, so we start on the first row, and we say while I is smaller than 3, so that's 3 rows, 0, 1 and 2, and I must be incremented by 1 every time. Okay, so we're going to count 0, 1, 2. All right, and then inside the block of the for loop you have total momentum, and then I've got a little plus equals there. All right, that's a little shorthand way of also adding something to itself. So I could have said, for instance, A equals A plus B. Alright, that's more how you normally, your mind is used to that from maths. A equals A plus B. But you could also just say A plus equals B. It does the exact same thing as A equals A plus B. So it's a little bit less to write. So in this case, when I'm saying total momentum plus equals, it's the same as saying total momentum equals total momentum plus. Alright, and then we're looking at the array again. So now we're saying the 2D array using that I as the row, okay, that index. Now currently I is 0, so we are in the first row of the array, okay, and we're taking that value, which was 50 kilograms, alright, and we're multiplying it by the speed, alright, of that row, alright, or of the second cell in that row. So remember that row consists of the values 50 and 1. Okay, the second row consists of the values 25 and 3.184, and the third consists of 150.5 and 1.8 meters per second. Now if we add all that up, all right, so we run this loop. Now let's say there were 10 million items. This loop will look the exact same. The only difference is here where it says where I is smaller than 3, that will change to 10 million. Okay, so it'll count through every single item in that array, add all up the individual momentums, and what we want is a grand total of all those momentums. So this basically shows you for loops are extremely popular because, well, it's a very simple loop to create. Well, most loops are, but it's a simple loop to create. and it's also very efficient or very easy to use when you are trying to go through something like an array, something with multiple indexes, extremely quickly, and like do some calculation on all these indexes or something that you're going through. But for loops are extremely fast. Okay, and then that brings us on to our next loop, which is the while loop. So one of the big differences between the for loop and a loop such as the while loop is the fact that the for loop has got that index counter that tells you the current iteration that is running through in the loop, whereas a while loop has nothing like it. It just runs forever. So the only way of breaking out of a while loop is you writing some kind of conditional statement to break out. So if you wanted to break out, for instance, after the 10th loop, you're going to have to create yourself a little variable called I or loop counter or something, and every time the loop goes through once, you increment that variable, and then you'll notice here it says while and then Boolean condition. The Boolean condition you can then make while I is smaller than 10, for instance, and then inside where it says do something, you'll be incrementing I all the time. So you'll be doing a while loop that way. So, but the other big thing with a while loop is that a while loop may never execute. It could execute, but it could not execute. Now the reason why I'm saying that is if you notice, it says while and then the Boolean condition. Now that Boolean condition can already fail before the while loop has even gone in the first time. Okay, so what I'm saying is, let's say for instance you want to know, you want to go through a list of your friends, and if your friend is older than 50, you want to do something every single day up until their next birthday. Alright, but that's only if your friend is, let's say, from 50. Okay, so in your while, in the Boolean condition, you can say there that while friend age equals 50. Okay, then it'll go in that loop, and it'll stay in that loop for as long as they are 50. And then when they are no longer 50, you've got to change the variable and say they're no longer 50, and then the while will stop executing. Okay, so it's actually a very simple loop to use. I do use it from time to time, but I still think the for loop is used more often. Then at the bottom here of this page, you'll notice I've got three little while examples there. While 1 equal 1, while true, and while 1 equal 2. So it's quite clear that the first case, while 1 equal 1, remember a double equal means that you are doing a Boolean comparison. So not making 1 equal 1, you're comparing 1 to 1. And so obviously this is true, 1 is equal to 1, and therefore it'll execute the loop. The second example is if you just have, like, let's say it's a Boolean that you've got stuck in there, a variable. It's got a value of true or false. So quite clearly in this case, the while loop will also be executed at least once until that Boolean changes. But the last case, where it's while 1 equal 2, well, 1 is never going to be equal to 2. All right, so in that case, the Boolean, the loop statement will never be executed. It'll never get in there. Right, and that brings us to our final point of discussion in this video, and that is going to be the do while loop. All right. So a difference between the previous loop and this one is that on the previous one, a Boolean evaluation was done up front, okay, before the loop executed. In this case, it's done after the loop is executed at least once. All right, because the Boolean is the evaluation is only done the first time after the loop has run through at least once. Okay, so if you look at the examples again here from left to right at the bottom, we have a counter. This is the same as with the for loop, having the I index that you can increment all the time, which the previous loop doesn't have, and this one also doesn't have. So if you want like a counter or something and break out at a certain point, you have to write that code yourself. And this is an example of exactly how you would do that. So you would create yourself a variable outside of the loop. In this case I called it counter, and then inside the loop at some point you have to increment it. So I say counter plus plus, so it's incremented by 1, and then it's now it goes outside of the statements being executed in the loop block, and then it does this conditional comparator, all right, and it's comparison, and it says, okay, do the loop while counter is less than 100. So it's done it the first time already, okay, and then he's incremented counter because he's done it the first time, but he'll keep doing it while counter is less than 100. All right, and this loop will keep going for 100 times, and when counter plus plus finally changes the value of counter to be 100, then this while counter smaller than 100 will cause the loop to escape, and the code will continue beyond that. In the second example, okay, we're just dealing with, all we're going to be doing is setting a Boolean that's got the value of false initially. It gets into the loop, because remember it always goes into the loop at least once with a do while loop, okay, and it then sets the Boolean to true, all right, and then it does an evaluation of it in the while, and it says do this while do escape. That means while true, all right. If you just say do escape, then he assumes it's a Boolean, okay? So while do escape is true. So the problem here is this is also going to be an infinite loop. So we basically set the Boolean initially, okay, to the value false, which is what would have allowed it to escape out of the loop. But now in this loop, we change its value to be true, okay? And that causes the breakout, the evaluation, never to come as a false. So in other words, that'll be an infinite loop. All right, also something you don't want. Okay, and then the very last one also is an infinite loop, and so what it'll do there is it'll execute the loop at the first time, then it'll do the conditional check. And it'll say, well, does 1 equal 2? No, it doesn't. So therefore, it equates to a false, not a true. So it'll redo the loop, and it'll just keep redoing it forever. And that means it's also an infinite loop. You must watch out for infinite loops. You don't want to get your program hung. It's very easy to write a loop where your program does just sit in this loop for a very long time. Try and concentrate on not doing that. But like I say, the loop you'll probably use most often is the for loop. There are some other loops as well, which we will cover in our C# course, but that's for later. Okay, so well, congratulations. The initial part of this series, the introduction to basic software development, is now complete. Everything I've said so far is very similar or basically the same for every language. A lot of the other things we're going to discuss further is also going to be the same for other languages, but we're going to now start specifically concentrating on using C# code. And yeah, like again, I say congratulations, and I'll see you on the next video. The fun is about to start. See you guys. Bye bye.